A Planck black hole is not just a small black hole. It is the limit. Nothing smaller than it can exist in the universe, measuring the Planck length of 10 to the minus 35th meters.
An atom compared to it is like the whole observable universe compared to an atom.
Such a thing is impossible to create, impossible to detect, impossible to study with any tools we have. It exists only because math allows it. This is the lower limit of a black hole's size, the boundary beyond which physics stops working as we understand it. Nothing can be smaller. Primordial black hole. It wasn't born from a star. It's older than any star in the universe, older than any galaxy. In the first fractions of a second after the Big Bang, the universe was uneven, denser in some places, thinner in others. The dense regions collapsed straight into black holes. No explosions, no stars, just the compression of matter under its own gravity. Some of them are the size of a proton, some mountain-sized, some the size of a whole planet. If they survived 14 billion years, they're out there somewhere right now.
Some scientists think they are dark matter, the very thing we have been looking for decades and just cannot find.
A stellar black hole is born from death. A massive star burns all its fuel and explodes as a supernova. The core collapses in seconds. The mass of several suns is compressed to the size of a small city. In our galaxy, there are about 100 million of them. Out of 100 million black holes in the Milky Way, we've found only a few dozen. The rest just hang in the dark. No light, no signal, no way to detect them if there is no star nearby that they are devouring. We will never find most of them. Intermediate black hole. For a long time, no one was sure they exist. Too big to be born from a single star. Too small to sit in the center of a galaxy. From 100 to 100,000 solar masses. A gap in theory no one could fill for decades. We have stellar ones, supermassive ones, and emptiness between. In 2020, gravitational wave detector LIGO recorded two black holes merging. The result of the merger is intermediate, the first direct proof of their existence in the entire history of observations. The gap is closed. A supermassive black hole sits in almost every galaxy's center. In ours is Sagittarius A, 4 million solar masses. We have known that it was there for decades. Stars near the center of the galaxy moved too fast. Something huge held them in orbit, but it was never seen. In 2022, this changed. Scientists all over the world, 8 telescopes on different continents, working like a single Earth-sized antenna. And still, we only saw a shadow, the boundary from which not even light returns. An ultra-massive black hole. Some black holes make supermassive ones look small. TON 618, 66 billion solar masses. Its event horizon is 200 times larger than our entire solar system. If you put it in place of the sun, it would swallow everything up to Pluto's orbit and keep going. Such objects shouldn't have had time to grow during the universe's existence. The universe simply isn't old enough to create them, according to our models. But they exist, and we still don't understand how. A binary black hole. 2 black holes orbit each other, getting closer over millions of years. Their gravity distorts space-time itself, creating ripples that spread across the entire universe. Gravitational waves. In 2015, the LIGO detector caught this signal for the first time. 2 black holes merged 1.5 billion light years away from us. The whole event lasted fractions of a second. In those fractions of a second, more energy was released than all the stars in the observable universe emit in a whole second. Combined, we felt it here. A wandering black hole. There are black holes without a galaxy, without a center, without anything nearby, just drifting through interstellar space, all alone. In 2023, astronomers found the first confirmed wandering black hole. 7 solar masses. No accretion disk, no radiation. It was discovered only because it accidentally passed in front of a distant star and distorted its light. If it had passed slightly to the side, we would never have known of its existence. How many of them are drifting through our galaxy right now is unknown. An X-ray binary system. That is exactly how we found the first black hole in history. Cygnus X1. 1964. A black hole next to a companion star, slowly pulling gas from it. Gas swirls into a disk around the hole, heating to 10 million degrees, begins glowing in the X-ray spectrum, so brightly it can be seen from another galaxy. We did not see the hole itself. We saw what it does to the star nearby, the gas tearing off of it, the disk heating up. We did not see the hunter. We saw the victim. Quasars are the brightest objects in the universe. A supermassive black hole at a distant galaxy's center actively consumes vast matter. Its disk heats to billions of degrees, shines brighter than 100 billion stars. A whole galaxy. A known quasar is 13 billion light years away from us. The light we see today left before the sun appeared, before the Earth appeared, before the solar system appeared. We are looking at an object as it was almost at the very beginning of the universe. A blazar is a quasar pointing right at us. A jet of plasma, a stream of charged particles accelerated almost to the speed of light, flies right towards us. This makes a blazar far brighter than a quasar, the most energetic, constant source of radiation in the universe. The closest known blazar, Markarian 421, 400 million light years from Earth. That's such a distance, it is absolutely safe. If it were a few light years away from us, its radiation would burn away the Earth's atmosphere in seconds. A naked singularity is a black hole that has no event horizon. A singularity is a point of infinite density, directly exposed. No protective shell. No boundary. Roger Penrose, in 1969, suggested that nature does not allow this. It always hides the singularity behind an event horizon. He called it cosmic censorship. But math finds exceptions. A fast enough spinning black hole can theoretically expose its singularity. What an observer would see, looking at it directly, physics cannot answer. There, its laws simply end completely. A Kugelblitz is a black hole, not created from matter, but from light, from photons. Focus enough light in one point of space. The energy of photons creates mass. Mass creates gravity. Gravity collapses space. In nature, this has never been observed anywhere. But in the very first moments after the Big Bang, when the radiation density in the universe was monstrous, this could happen by itself, everywhere. A black hole born not from a star, not from an explosion, but from pure light. A microscopic black hole, smaller than a proton. If our universe has extra spatial dimensions that we do not know about, such black holes could be born right in the Large Hadron Collider when particles collide at huge speeds, appearing and instantly evaporating via Hawking radiation in a fraction of a second. No danger to Earth, but finding them would prove space has more than 3 dimensions. Physicists have searched since the collider launched. Still haven't found them. A killer black hole. A black hole doesn't hunt. It just exists. But if a star gets too close, tidal forces tear it apart, literally stretching it into a long thread of gas. This thread wraps around the black hole. Some matter is consumed. Some is thrown back into space at enormous speed. A flash as bright as trillions of suns is visible for billions of light years. The star existed billions of years, survived everything, died in a few hours. Just got too close. A white hole is the mathematical opposite of a black hole. Nothing can enter a black hole and come back out. Nothing can enter a white hole, only exit. It follows from the exact same Einstein equations that describe black holes. No one has ever observed one. No one knows if they even exist in nature. Some physicists suggest that the Big Bang itself was a white hole, an ejection of matter from another universe. Everything around us, every star, every galaxy, every atom, flew out of it at the very beginning. A wormhole is a tunnel through space-time. 2 places in the universe, connected directly by a short path. Billions of light years distance in one step. General relativity doesn't forbid their existence. The equations allow it. But a stable, traversable wormhole needs exotic matter with negative energy, which no one has ever observed or created.
An unstable one will collapse faster than even a photon of light can pass through it. We don't know if they exist in nature.
The equations leave the possibility. Reality remains silent for now. The black hole of last light. In 10 to the 100th years, all stars fade. Galaxies scatter. Planets decay. Only black holes remain. They will dominate the universe for trillions of years, slowly losing mass through Hawking radiation, evaporating. The last of them, and the most massive of all that ever existed, will last the longest.
When it finally disappears, there will be no matter left in the universe. No light, no motion, no structure, nothing at all. Just endless, cold emptiness, forever.
That's all we know about black holes. Bye.
Every year brings new discoveries. Every year, the theory changes.
What we thought was true 10 years ago isn't today. Who knows what they'll find tomorrow? Write in the comments which black hole from this list seemed the weirdest to you. And subscribe, and I'll try to make an even more educational video for you. See ya.